Bjorn, and together with Saurabh, we're going to present AkerBP's digital lab called Eureka. And AkerBP is exploration and production oil company. So, yeah, we'll just move right into it. And thank you so much for coming. I see there's still coming people there, yeah. So the agenda today is, first of all, we're going to start to talk about the digital lab itself and how we work. And then we're going to move into some use cases that we have built up and also try to do a live demo of the use cases that we have built. It's running on my mobile phone, so I'm a bit the internet because I couldn't get access, so I hope it's going to work. So we're going to start off with a video of explaining what Eureka is, and I'm going to collaborate on that afterwards. But we're moving into how Eureka is structured. We are actually about 160 people working on digitalization now in Eureka. And as you can see here, we have a sponsor group at the top. We have the PMO, Program Managing Office, and we have an overground and an underground tribe with different crews. And me and Saurabh, who are presenting today, are part of the Smart Maintenance crew. So we're going to collaborate a little more on that. So the next thing I want to talk about is the heartbeat, the way we work. So what we do every day is something called stand-ups, where we maximum talk for 15 minutes about what we did yesterday and what will we do today, and help each other figure out what is the best things to work on. We also have the heartbeat is a 2-week rhythm, as it says there, consisting of these ceremonies. The first week, on a Thursday, we have the internal demo, where we help each other. And the second week, we have the external demos, where we have externals from our organization coming in and helping us with developing the different solutions. Straight after the external demo, we start planning the next sprint, the next 2 weeks. And we also have a retrospective. How did this go? The retrospective is internal. How do we work, and how do we improve the way that we work internally? And we also have anchors and icebergs once a week, where we look into what is slowing us down right now, the anchors, and what are potential big problems with the icebergs. And we also have bi-weekly cross-crew learnings. Like I said, we are 8 different crews with different fields, but still it has happened that we have started to work on the same things, so it's very important to align the crews. And we also try to do as many knowledge sessions as possible, so we can learn. If you are a data scientist or you are an engineer, we are working in multidisciplinary teams, so there's a lot to learn from each other. So this is the way we work. We are not only AkerBP people in the lab, there's a lot of people included. For example, we have Cognite, who is responsible for giving us our data lake, and they also help us with developing the use cases and putting it in an environment. We also have consultants helping us. We have a lot of companies helping us with collecting the data and putting it in the same place, which is the data lake of Cognite. And we have also worked with a couple of companies with advanced analytics, and we're working on smarter contracts where we pay for uptime. So here are the companies we are working with in smart maintenance, but there are also more companies involved in the other crews. So now we're going to move more into the use cases. And the first use cases we're going to talk about is more into the structure for where we put them in and how we have developed them. So we have one system for condition monitoring and analytics. We started to develop this with Cognite, and this is called operational intelligence. So this is a way where we drill down from the top. We go into the rig asset, because we operate different rigs who has different ways of working, and we're trying to standardize that more and more. So you can work your way from the top, move into different equipment groups and subsystems, and then drill all the way down on tag-specific equipments. And now we're gonna try to do the live demonstration of operation intelligence. So here you see something that we call health dashboards, where you can start at the top here and select your asset, your rig asset. And then, like I said, we work in use cases. So for the starting point here, we have included on-off valves as well as fire dampers, and have started to work on pumps. So what you can do, you can either press all equipment, and then you can see all of the equipment we have put in here and see how many are healthy and how many are not. Or you can drill down to on-off valves and different types of on-off valves and see how they are doing, and take many at a time. So let's see. And like I said, now we've gone more into different equipment categories, but you can also drill down to specific tags. And when it comes to valves, we have found that there are some requirements. You have the months since last operation. It has to operate once every 6 months. You also have the time it takes for the valve to close, and this comes in with live data once an hour. And then you take the newest result of the operation for one tag, and you compare it to the maximum limit that you have set in your asset. And you can also filter on all of these different requirements and move further into specific tags. And it worked. So here for all tags is the point to have these 4 tabs where you can go into details, you can go into the different time series for each tag. For example, for valves, you have, it's difficult to see from the time series names, but you have the MTTC is max travel time for closing. So that's just a constant value that will just say I'm still 20, I'm still 20. And if you change the requirement, this will change here as well. And then you can go into the travel time for closing, the last operation. And you can go into the reaction time as well. And then you have documents and events for the different tags as well. But this is one way of doing it. What if you are interested in one specific tag? You can also just search for it in the Asset Explorer. You can click it, and you see the same tabs that you saw when you drilled down from the top. But what you can also do now, we're continuously improving this platform. What you can also do now is that you can go in and create dashboards. So here you have a chart, and then you have specific time series, as you saw in the previous view, that you can use to create a dashboard for the different tags. So for example, now I can use the max travel time for closing, the actual last travel time, and the reaction time for closing. And then I can bring them up on the same graph. Let's see here. Yeah, so then you get everything in the same graph, and you can compare it if it's having a bad trend or not. You are also supposed to be able to bring all the y-axes together so you see them on the same plot. But for some reason, that function didn't work now. But yeah, that was the demo we had now for Upint, and now Saurabh will continue coming more into predictive maintenance that we're working on.
Yeah. So I'm going to present a little bit more into advanced analytics, which we are doing in Eureka in AkerBP. Maybe we should just zoom it. Yeah. So the use case on which I'm working, it comprises of a team of engineers who are the first line engineers, mechanical, electrical, process engineers, and domain experts like myself. So we are outsourced from AkerBP into Eureka. And then we have data scientists from different partners working on this. We have a company, a US-based, Austin-based company called Spark Cognition, who are supporting us on machine learning modeling for this use case. So what is this use case? It's based on a normally unmanned platform called Tambar, which you see there. And it's around 16 kilometers far from Ula. So and there is a pipeline established from here. This is a small platform, and it doesn't have the capacity to do the separation of the crude which is coming out from this field. So we have a multi-phase pump which is installed on this platform, and its purpose is to push, to create the required pressure and flow to push all the crude to Ula platform where further processing and separation could be done. So moving on to the next one. This is the multi-phase pump. There's a small video on that. Yeah. So it's the pump here with the mixing tank on top, and it looks quite simple from outside, but it's a lot of complication there, and it has a history of a lot of failures. There were the most common failure was seal failure, which was caused because we received the slugging from the wells. So there's a lot of different regime of pressures which act on the crude when the wells are connected to the field and the crude is coming out. So it's very unpredictable. And this pump is bearing all those pressure changes in that, and the seals are breaking out very, very frequently. So we wanted to predict how these seals are working, and if we can find out when they are supposed to fail, then it would save a lot, because this pump, if it stops, it causes around 4,000 to 5,000 barrels of production loss per day, and that is around 2.5 million NOK of production loss per day. So to define a use case to justify machine learning model is very easy in this case. Yeah, and this is the seal system which you're seeing. And this is the assembly of the seal system. So there are a lot of small components which are involved in this. And now you're seeing the bearings which are holding the axle. Yeah. So just for those people who are not much into the machine learning models, I want to just compare it with designing a table. How a table is designed and how similar is it to the machine learning models. So what do you do first? You need to define the system boundary. And to define a system boundary, you need to identify an area, for example, in a jungle, where you want to collect the wood from. So in our case, this is the flow diagram of the system. Here you could see this is the multi-phase pump. You have the gearbox, you have the motor, and a variable speed drive. You have the lube oil tank providing lubrication to all the bearings, and you have the seal oil tank providing the right pressure to the seals. And here you have the wells. So what is the system boundary? We need to define that in a proper way, that we consider that we will not consider the wells in our scope. We will not consider the further separation systems in our scope. So it's very important to define that part. Once you have defined it, you need to identify the sensors. So if we compare the table, the wood is the sensors. And you need to select what kind of sensors you need, because it really helps you to identify what kind of model you're making, what kind of table you are developing. If you select bamboo trees here, you will have another kind of table. So the right sensors is important to choose here. Then you need to have you need to build a data architecture to the data lake, which is also very important, because you need to once you have identified the sensors, you have the data points, and all those data points needs to be collected in a data lake. So we have established that using Cognite Data Platform. That's our partner company. And then when you have got the data lake, all the data is coming there, you need to have a structured way in which the data is arranged there. And that's how you identify the missing sensors. So this is a control system diagram in which we have identified the different sensors. So the green ones are the sensors which are transmitting data offshore, from offshore to onshore, but the red ones were the data which is available offshore, but it was not transmitting to onshore for further analytics. So we identified those data points, we activated those with our partners, and now everything is available. Once this is there, then we need to establish another pipeline to feed the model. So wherever the model is being developed, we need to feed all this data from the data lake to the model platform. And that's what we have established. So here you could see this is the Cognite data platform, and this is Spark Predict. That's the Spark Cognition's application in which the model is being developed. So all that data is getting feeded up to Spark Predict, and then we have developed a feedback loop as well. So the model output is going back into CDP, and then we are using that to develop our own dashboards to display all the real-time data. And we learn from failures as well. So what happened in the history of the pump, for example? What was how these pumps were behaving? And that's the key thing to understand how to train the model, how to test the model, and validate the model. So we looked into these kinds of time periods. So you have the daily logs, the weekly logs from offshore operators who are looking into all of this and who are recording all this information. We have identified them as different kinds of failures, different categories, and then we are using that information in our modeling. And then we check the data. So how do we check the data? It's more like you see here. We have identified the periods so these vertical lines are the different events which are happening in the history of the data. And we see here when we populate the data, we identify how good the data is. For example, if we are monitoring every second, the red ones are the ones which are telling that the data is available during that period. The violet ones are here in the scale, which is telling the data is not available. So it also depends on how frequently you want to capture the data. What is the right interval of capturing the data? And that is, for example, if we do it every 5 minutes or so, we will have everything red in this case. And then it's model development. So then when we have all this data available in the right way, we start the model development part. We look into the correlation between the different sensors. For example, we have the temperature transmitters here, and we have some other temperature transmitters. How they are correlated to each other, it's also very important to understand. And then after that, we make an ambition. That's what should be the model output, how it should look. So here you could see this is how the risk score is coming out, or the anomaly score is coming out. And you have a threshold limit which is established. As soon as it gets above the threshold limit, the model should send notifications to the end users. And the end users should go into a little bit more deep diving to understand what is actually happening. And you see a set of sensors which are classified here as time series, as giving the anomaly score as output. And you can see how this is something started developing here. So the red ones are the ones which are having higher anomaly score compared to the other sensors. So we could see initial trends of how this is developing to a real case failure. So this is the real prediction which we want to achieve. And that was a mock-up which was done. And then we choose the different types of machine learning models which could be utilized in our case. For example, here you have different kinds of models. You could use supervised, you could use unsupervised, or you could use a combination of them. In our case, we used a normal behavior model because because the pump was failing very frequently, and it has several design changes. So we needed to consider a model which is suitable for that. And then when we have identified the model, which model we need to go forward with, we do the model training and retraining. That is important to understand if the model is giving the right accuracy in prediction. So how do we do training? So you could see here, it's like you have one failure, which you could see here. This is a failure due to a vibration issue. Another event is happening here, a seal breakdown. And there is a normal running period in between. Now, what typically we do is that we take around 60 to 70% of that period and use it for training the model and validation. And then the remaining 30 to 40% is used for testing the model. So this is the ideal case. These normal periods could vary in size, and there may be some time where you have insufficient data. So we can't use the model for training or retraining in this case. But in reality, it's a lot more complicated because there may be multiple RPMs, multiple speeds in which the pump is running. There may be a bypass arrangement which is opened. So we have to consider a lot of different combination of a running regime, how the equipment is running. So it is quite complex in reality. And then when we have built up the whole model, we come up with a kind of a primitive version of the model, which is very basic model, which looks into different kinds of sensors, which we have focused it. And then we start the training and retraining period. And then it becomes as a final model which is ready for deployment. So I will show a dashboard in which we have the final model which is ready for the deployment. But one of the important things is that after deployment, what happens is that you need to establish a feedback loop from the end user, in between the end user and the data scientist. Because the end users need to tell if it's a true positive, or if it's a false positive, or a false negative. This example is typically telling, for example, this sensor is a differential pressure transmitter, which is telling that there is a rise in the differential pressure, and then there is a step drop in the differential pressure. When we send this kind of information to the end user, the first line users, they need to tell if it's a true positive, if it's really an anomaly, or it's something which is just noise. So this actually was that the differential pressure was increasing, and then they changed the filter cartridge. So the pressure went down. So it was a false positive alarm. And that kind of feedback needs to go back to the data scientist to do the retraining. So the model will understand that, okay, if this kind of trend is appearing, I don't need to flag it up again and say that this is an anomaly. So that kind of feedback is very key to having a more accurate model. And the machine learning it actually means that the number of good feedbacks you receive, the model learns itself, and it becomes more precise and accurate. So demo of the dashboard quickly. So we built, as I told about the architecture, we had everything going back from Spark Predict into our Cognite data lake. And from there, we pulled it through APIs into Power BI application, and we have built this dashboard. So this dashboard is a real-time dashboard which is telling how the model is behaving today. So you see this one is telling the risk curve. This is the threshold. If it's above this, it's very high risk. So today the pump is not running, and that's why it's showing this value. At any point of time, you could see the risk score and the threshold value. And these are the dominant sensors which are responsible for that kind of risk. So this this is in real time. This is actually today how the pump is behaving. And then if we want to dig down and understand what is actually happening in the pump, we have another dashboard which is looking into the history. So it tells about the risk here. The same risk score is coming here, but it's for a longer period of time, just to cater our data. There's a lot of data coming in through the API, so the application should also run. That's why we have kept this as a separate dashboard, and it's updated once a day. The other dashboard which I showed, that is updated every hour because it has less data and it shows real time. In this one, what you are seeing is the dominant sensors at any particular time. So you can actually select a period and you will see, I think it's the internet, or yeah, you can see. So this whole thing changes. So at any period of time, we are telling this is starting from sometime in February and ending on yeah. So it's between that period. We are seeing how the sensors are behaving. And this is the flow diagram, which is also very dynamic. You could actually see real-time information of which sensors are behaving in an absurd way. You could see the real-time most recent value on the sensor. You could see the average sensor value for the period which we have selected here. So if we select something like this, it gives, this whole thing is changing. What you could do more here is that if you select this particular sensor, it gives the raw data, which is the sensor value at any point of time. So this is a good comparison of between the anomaly score and the raw data, raw sensor data. So how the sensor is behaving. And this is what we are going to launch to the end users, who are the offshore technicians and onshore first line engineers. So they are supposed to look into the historical part as soon as they get an alert notification that something is happening and the anomaly score is going high up and we have high risk in this. Yeah. So I think that's it. And then you have, after doing all this training and retraining, this is how you continue the journey. The model will become more perfected, more refined, and it goes on. So questions or comments?